Good day, learners. Welcome back to our chemistry class. Today is going to be the continuation of our volumetric analysis, that is, preparation of standard solution. If you could recall in our previous classes, if you could recall in our previous class, we discussed on preparation of standard solution from primary standard. And the first one we talked about is the weighing method. Today, we are going to be looking at the dilution method. Before we venture into this properly, if you are a new member on this channel and you've not subscribed to my channel, kindly do so and click the notification bell for my subsequent content. When you click the bell, it gives a prompt. Click the personalize and then you can be seeing my subsequent lessons. So let's proceed. Dilution method. This method is used in preparing solution of low concentration from a solution of high concentration. Given a solution of high concentration, we have to prepare a solution of low concentration by the method of dilution, the use of distilled water to dilute a high concentrated substance to give a low concentrated substance. Now, meaning that we are going to have two concentrations and two volumes. The first solution is more concentrated than the second solution, while the volume of the second solution will be higher than the volume of the first solution. But the amount of substances present in both first solution and second solution remains the same. Volume can increase, concentration can change, but the amount of substances that are present there from the initial to final will not change. We should know that number of mole amount equals to concentration times volume. For the first substance, let's say N1 is equals to C1 V1. That is first concentration multiplied by the first volume. N2 will be equals to C2 V2. Since we know that no amount of the substance will not change, meaning N1 will equals to N2, and our N1 is C1 V1 equals to C2 V2. So C1 V1 is equals to C2 V2 is called dilution method or law of dilution. Now, in this place, our C1, the first concentration of the solution, is greater than the second concentration. But our V2 is greater than the V1. Why? Because the volume here, water has been added here to give V2. So we will expect the volume, second volume, to be higher in volume, to be much in volume than the first volume. So V2 will be equals to what? V1. But from this place, we can move forward by saying C1 over C2 will be equals to V2 over V1. You know, when you cross multiply, C1 will go to V1, we have this, C2 go to V2, we have this. So this is called dilution factor. Dilution factor. Meaning the number of times the substance is being diluted. So C1 over C2 is equals to V2 over V1 is called dilution factor. Now, to now know the volume of water added to the substance, the volume of water that was used in dilution is going to be V2 minus V1. Volume of water for dilution will be V2 minus V1 in unit volume. The unit is a centimeter cube. If it is decimeter cube, but the unit must be the same. Example 1, if 10.0 centimeter cube of a solution of a 2.0 mole per dm cube HNO3 were diluted with water to obtain a solution of 0.100 mole per dm cube, calculate the question A, dilution factor, B, final volume of solution, C, volume of distilled water. Okay, here, if 10.0 centimeter cube, that is the first volume, V1, 10.0 centimeter cube, and the first concentration there is C1, that's concentration of the HCl, HNO3 rather, 2.0 mole per dm cube, while the second concentration C2 equals to 0.100 mole per dm cube. Now, the first question, we are asked to find the dilution factor. Don't forget that C1 over C2 will equals to V2 over V1. Here now, we only have V1, we don't have V2. Okay, so we are going to make use of C1 and C2 because we have this. So this dilution factor now, dilution factor here will equals to C1 over C2, so which is equals to, our C1 is 2.0 divided by 0.1. So here we have 20. We have 20. So which means that the dilution factor is equals to 20. Question B, want to find the final volume of solution. Now, from this now, since we have our dilution factor here, we can get our final volume, which is our V2, since we have our V1. So question B, V2 over V1 will equals to, so this one now has given us 20. Let's say over 1, cross multiply, V2 times 1. So, okay, let me say V2 divided by, my V1 given here is 10. So it's equals to 20 over 1. So cross multiply, V2 times 1, I have V2 is equals to 10 times 20, I have 200, so centimeter cube. So the final volume of this solution is 200 centimeter cube, while the initial volume here is 10 centimeter cube. To get the volume of distilled water is going to be equal to V2 minus V1. That is, our V2 is 200 minus the first volume given to us here is 10. So 200 minus 10, we have 190 centimeter cube. So this is the volume of distilled water. Example 2. The stock solution of concentrated H2SO4 is 18.0 mole per dm cube. Calculate the volume of the stock solution in centimeter cube that should be diluted in order to obtain 10.0 dm cube of a 0.100 mole per dm cube solution. Now, let's look at this. The stock solution of concentrated H2SO4 is 18.0 mole per dm cube. Anything in mole per dm cube, we know is that is concentration. That is concentration of that H2SO4. That is the C1. C1 is 18.0 mole per dm cube. Calculate the volume. The first volume is going to be our V1. Volume of that H2SO4 is unknown to be calculated. Calculate the volume of the stock solution in centimeter cube that should be diluted in order to obtain 10.0 dm cube. Anything in dm cube, you know, is in volume. Our V2 equals to 10.0 decimeter cube. Then the concentration, our C2, concentration of this H2SO4 is 0.100 mole per dm cube. Now I want to calculate our V1, but in centimeter cube. Since we are given this one in dm cube, the first thing is to get it in dm cube and then change it back to a centimeter cube. From here, you know that C1 V1 equals to C2 V2. I want to get my V1. V1 will be equals to C2 V2 over C1. So my C2 is 0.100 0.100 multiplied by my V2 10.0 divided by my C1 18. So when I multiply this, I have 1.00 divided by 18. So when we divide, what do we have? So V1 equals to 0.056. This is decimeter cube. But we are asked to find it in centimeter cube. So in this case, we multiply by 1000. My V1 will equal to 0.056 multiplied by 1000. So we have 56 centimeter cube. So this is how to calculate the concentration of volume using the dilution method. So you can lay your hands on the exercises coming shortly. I remain Latif Ismaila Akombi, your mathematics and chemistry tutor. So stay tuned till we release the next video to move into titration proper. Thank you very much.